All right, we should be streaming for World Quant. Welcome everyone. I am back today, but I'll be gone tomorrow. So I'll be here today, gone tomorrow. So Russ will fill you in for tomorrow, FYI, at 12:30 UTC time. But let's see who is joining us so far. I see Ragav. There was a there was an issue with the pod. So there's an issue with our grader server today. There was about a 2-hour outage. We fixed it. You're good to go. All right, and I see Dara J is here, Renato is here, Suleiman is here. Welcome to Unit 2, World Quant Office Hours, going to the course, Machine Learning. I believe Russ worked through Q4 of the mini project. So we did Q4, so that leaves us with Q5. That all is left. So cell, run all above. Let's wait a little more people to come in. All right. This is still running. Probably have a very longer programmatic model running in the background, so things are a little slow, but I think we can move on. And previously yesterday, you worked with Russ for Q4, I believe. Working with bringing in the simple categories and the categorical features to have a better model. I see a question here from Narayan. I saw the video on MLQ2, which shows pipelines and closing grid search, and also a pipeline within a grid search. Should these not be run on training data and tested separately on test set? I see Raymond is here. Welcome, Raymond. So I see, so one of the videos we show you two ways we can do things. Wrap a pipeline in grid search or have grid search as the final step of the pipeline. Two different approaches to this. And should these not be run on training data and tested separately on a test set? Either way, they should be trained, either of these approaches should be trained on training. Either of these approaches, and tested on test set. So either one should indeed be used to be trained using the training data. Should be fitted with the training data. Someone says, is this Unit 1 or Unit 2? I'll let you guess. Narayan, let me know if that answers your question. I do want to make sure I answered your question. All right, I see. So we just do a train test split and then fit it with the training data. Great. The either approach, right? You do train test split, one of the very first things you do, and you fit on the training. Exactly. Should be the same approach whether you have a grid search on a pipeline or grid search, whether you have grid search over your pipeline, whether you have grid search as a step in the pipeline. You do train test split and you train on the training. Okay, anything else? Other questions we want to bring up right now? All right, good to hear. Yep, thank you, Mickey. I am back today, but I'll be gone tomorrow. Okay. All right, so go ahead and keep on putting things in the chat. Will always keep an eye on that. Let's look at Q5. In the meantime, let's transition to Q5 because I believe you worked on Q4 with Russ. Surveys reveal safety and health deficiencies at nursing homes that may indicate risks for incidents. Penalties. CMS routinely makes surveys of nursing homes, build a model that combines the business features of each facility with its Cycle 1 survey results, as well as a time in between Cycle 1 and Cycle 2 survey results to predict the Cycle 2 score. So it looks like what we want to do is we view our workflow. Here comes our data. We have a separate step about these business features, call it BF. We have a second step where we're going to include the survey results. And finally, a third parallel step with time-based features. So one way we can put these steps in parallel is to wrap it in a transformer. Okay, that's what I gotta do. All right, I see someone here in the chat says your server's starting up, taking forever. Yeah, so we had, for some reason, our greater pod went down, so we had to restart the hub. So there might be some latencies that you might observe. So all we can do is just ask that you hold on. So thank you for your patience there. Okay. So in fact here we have a transformer. So we want to make use of two columns. Is this still running? This is still not running. Oh well, I can hit kill that. I think we should be fine. Let me just run a couple other cells here. I think we're fine. Let me double check. Sorry for the back and forth. Let's see. Categorical features. I think we're okay. Let's look at data. And we have two columns of interest. The Cycle 1 survey results, survey date. So cycle survey date. And we also have another column called Cycle 2 survey date. So there are two columns. And to work with time-based data, we gotta convert this date time object, these date time values, into something numeric. As we're learning here as we go through the curriculum is that these ML predictors, they need numbers to learn from. Tabular data as numbers. We have two things that are not numbers, they're datetime objects. So what typically we got to do with date features, we have to come up with some sort of numeric out of them. And a common way to go about doing that is to find the difference between the date with respect to some other date. So what we could do is we can create a feature. We can create a feature that is simply the time lapse between two dates and times. So in other words, I can do something like this. I can say data and say cycle 2 survey results, survey date, minus data cycle 1 survey results, and take the difference. But I take the difference of these two columns and I get an error. What do you think is going on? Why can't I simply subtract these two columns? What is holding me back from performing this arithmetic? Yeah, it needs to be a datetime string. Exactly, it's a string. So how can I do arithmetic on strings? I can't. Yeah, it's not a datetime. It looks like a datetime, but it's not a datetime. So exactly, Suleiman, exactly, Mickey. It needs to be a datetime. It's a string, Renato. Exactly as you pointed out. It's a string. So that's not too much of a problem. I know how I can do that, right? Specifically, it's an object, which refers to, it's an array, a series of Python objects, typically strings. So that's fine. I know there's in pandas a function called toDatetime, and I will give it the survey date. And okay, now indeed I convert it to a datetime. That's nice. Okay, so that means that I can still perform the arithmetic. I just got to be convert it into a datetime first. Put it there and switch this to 1, and now I can calculate the difference. So I calculate the difference, and there I go. I can perhaps flip 1 and 2 around. And I have the number of days that have elapsed. But I'm still not at a number, right? What I get, in fact, the data type here is a time delta. I'll call this delta t. I'll call this variable delta t. And I've made progress in encoding those two categories to be numbers, but I'm not quite done yet. I see the number of days. So what I could do is I can look at dt. If I want to do access attributes and methods of the datetime object, I'll call it the .dt attribute. Then what I'll do next, I will look at what I'm looking for. So notice I can look at things like week, year, frequency. I'm trying to look for, so if I look at one example, ilock 0. Look at one of those. And let's see what methods I have available. You can call the dir function. Show me all attributes available for that object. Let's see what might be of interest. I got days. Well, that might be interesting. Microseconds. Total seconds. Maybe what I can do is I can say dot total seconds. Looks like it's a function, so I'll just call it. And there appears to be a total number of seconds. So let's verify that. Delta t ilock of 0. 315 days. So 315 days times 686,400 seconds in a day, and I get the same number. Okay, so I can trust this result here. So I can convert the two columns into datetimes, timestamps, take their difference. I get a time delta object, which has an attribute called total seconds, which will give me the total seconds. And now let's do this for all of my columns. Notice I just did it for one of those. Let's see if I can do this for all of them. Yeah, there I go. There I go. Now I have done the proper encoding, where I have a column of nothing but numbers, floats. And this the model can process. So notice how we experimented, tried things out, played around with it. We're satisfied with our procedure. What do you think is our next step? What will be the next step in our workflow here? Now that I've arrived at something that seems to be working out decently, what would I do next? Yeah, exactly, Suleiman. Then we're ready to write the time delta transform. Exactly. Okay, so let's try that out, right? We got a couple of things. So notice we're going to initialize it with specifying the two columns to perform the difference. The fit method, we ask ourselves, well, let's actually do it the other way around. I think last time I said, let's write the transform method first, and that will infer what I need to learn in the fit method. So I take X, and I select my columns, self, T1 call. I got to convert this into a date time, to date time. I call this T1, set for T2, PD2 date time, self.T2 call, and then I can return T1 minus T2 and call DT total seconds. I think that does it. So notice nowhere in the transform method did I ask myself, oh, that is something I need to learn from the fit and training process. Nowhere did that come up. I was able to simply do the transformation with what was initialized with the object and the data. So there's nothing to learn in the fit. So we'll simply leave it as return self. But we have something that appears to work. Let's try it out. Let's go ahead and try it out. Time features, and let's say time features fit and transform data, and yeah, it appears to work. It appears to do what it's supposed to do. Questions people have? Okay, no questions there. Now, as always, when we come up with our solution, we code things up. We're always going to take a retrospective, right? A look back. Take a step back and critique what we have. So let's do that. I see a question here. Is there a reason why you are fitting on the whole data set here without a train test split? There's an argument to be made that we don't, there's an argument to be made. Not saying this is the best argument or this is correct, but there's an argument to be made that since the grader has held back a test set, we don't have to do a train test split because that test split the grader contains. So there's an argument to be made, and I will let you judge whether there's a sound argument or not, but there's an argument to be made that because the grader is using a test set that's already been split out, there's no need for us to do a train test split. I will ultimately let you decide whether you like that argument or not, and if you don't, you can always do a train test split. Any questions about this? I think it's a good question you bring up. Any questions about this? Okay, do let me know if you do want to further talk about this. I will take the argument, the approach. Can you elaborate on the nested SV approach recommended in scalar documentation here? Yeah, there's a nested grid search approach. I frankly have not played around with it, so I cannot talk about it right now, but I can always read the documentations and give my initial impression and suggestion. So let's see, scikit-learn nested CV. We'll take a look at this and see what it's about because I'm unfamiliar with it. Let's see what else is happening in the chat. Is there a transformation so you would not apply it to a test train split? But is it a transformation we still want to... Remember, there are transformers that learn from data. This transformer doesn't strictly learn from the data, but there are transformers that need to learn from the data. So we still need to do a train test split. I do get your argument that it's okay if we didn't because, well, it's not like we're learning from a test set to perform the transformation. But either way, I think it's, would you not apply? I think since we're ultimately trying to come up with I would not use it as an argument of why we wouldn't do a train test split. Because ultimately we're trying to build up to a model, some predictive model. And my argument here is that since the grader has a secret test set, we don't need to do a train test split. Take a look at this here. The examples compares non-nested and nested cross-validation strategies on a classifier of the iris dataset. Nested cross-validation is often used to train a model in which hyperparameters are needed to be optimized. Nested CV estimates the generalized model, their line model, choosing parameters and maximize non-nested CV biases, yielding an overly optimistic score. Choosing the parameters that maximize non-nested CV biases. Model selection without nested CV uses the same data for tune the model to validate performance information. It's totally agree with that. Magnitude of this effect is primarily dependent on the size of the dataset, stability of the model. To avoid this problem, nested CV effectively uses a series of train validation test splits in the inner loop, here executed by grid search CV. The score is approximately maximized by fitting the model to each training, directly maximized to select hyperparameter space of validation. In the outer loop, cross-val score, generalization error is estimated by averaging test scores across each train test split. Okay, let's see how it's actually being done. So num trials 30. Choose splits. Support vector machine with a nonlinear kernel to build a model with optimized hyperparameters by grid search. We compare the performance of non-nested CV strategies. So having a grid search as your final step, I totally agree. You technically have data leakage. So I can explain that. I can talk about that. So we say we have a model, A, B, and predictor, T1, T2, and our predictor. Now I can have a pipeline around the whole thing and then apply grid search. Or we can have, saying, we have our transformers, and we can have grid search around our predictor. And then wrap this all in a pipeline. Subtlety here. The first one, we set up T1, T2 predictor, and we wrap that in a pipeline, and we apply grid search on the entire pipeline. You do grid search CV, pipeline, with the pipeline model. The latter one is where you have a grid search around simply the predictor, and it's a step in the overall pipeline. Of these two approaches, mechanically, this one allows you to tune hyperparameters of all the steps in the workflow. It gives you access across all those hyperparameters of all the steps in the pipeline. So that's great. You have more options to tune. But the problem here is that if you're only concerned about the hyperparameters of the predictor, which typically are going to have a greater impact of the model, then you're going to find yourselves retraining the transformers every time. Because when you try a candidate, it has to start from the beginning all the way to the very end. So that's slow. We see more possibilities, more control, hyperparameters of everything in the model, all the steps, but slower. Instead, you can say, well, if we're only concerned about tuning the hyperparameters of my predictor, why don't I have a step in my process tuning the predictor, the grid search just around the predictor, just like what I have here, the circle being the predictor. Sorry, the circle being the grid search CV. Here, you're going to lose control. You cannot tune T1, T2. You can't tune their hyperparameters because grid search is only invoked around the predictor. We did grid search my predictor, my regressor, or my classifier. So that's a disadvantage, but if you only care about the predictor, then we have advantage because it's not going to refit all of the T1, T2s, all the upstream. Because that k-folds cross-validation strategy only begins at this step here. So less control, but faster to run. But there's something going on here that is subtle. It's not so obvious, but it's subtle. And that's the idea of data leakage, just like what it was expressed in the documentation. Well, data leakage means lots of things, but a form of data leakage that can happen is when your predictor is given some sort of piece of information that it isn't supposed to have. It is not supposed to have. Or giving you some sort of data that has been influenced with data it should not have access to. So for example, let's go a little more concrete to where this data leakage occurs. Let's say these transformers are something, let's say one of these transformers is a scalar, standard scalar, some sort of scalar. Well, a scalar is a transformer that actually learns from the data. So it learns how to scale the data, and what gets fed here is a transformed data set. And the way that was transformed, it used the entire training data to come up with that transformation, or to learn that proper transformation. So now if we apply k-folds cross-validation, 1, 2, 3, 4, and 5, we're going to train on 1, 2, 3, and 4, evaluate on 5, which seems okay. But this data set we have here has been influenced by what were the points in fold 5 upstream. Because our scalar, or any other transformer that learns from our data, strictly speaking upstream, learn from the entire training data. So then when we do this k-folds cross-validation, it's sort of weird how we hold back 5 and evaluate how well it does on 5, but we are using information about fold 5 to learn the transformation that occurred upstream. Somehow information about the holdout set has leaked into the data set. It's subtle. It's subtle. So I'll repeat that again. Up to this point here, I'm using the entire training data to learn the transformations. So data that comes into this last step has been influenced by the entire training data. So it's a little weird how I go ahead and learn on folds 1, 2, 3, and 4, evaluate on 5. Because it's not a true comparison. It's not a true fair comparison, a true fair evaluation, because the data that came into it was influenced by the holdout set, or part of the holdout set has been influenced the state of the data, the form, the state the data currently is present. So we have data leakage. So while this one is slower, strictly speaking does not have data leakage. While this one is faster, because we can only just focus on the predictor, strictly speaking there is data leakage. Of course, the effect of data leakage might not be so strong for a transformer like a scalar, but imagine we had a transformer that learned from labels, that learned through the training labels. So data that comes into the predictor has been influenced by the labels, and then we hold back those labels. It's a little bit weird. We have data leakage there. There are transformers that learn from the labels. Most of the transformers we see actually learn from just the observations, just the feature matrix, but there are transformers out there that actually make use of the labels to make a prediction, to make a transformation. This point is subtle here, so I do want to pause and open up for questions. So questions about this data leakage that's going on. Like target encoder, exactly. Classic example is the target encoder, exactly, Narayan. Because a target encoder, we use the labels to come up with a transformation. So the data that comes into the predictor has been influenced, the data that goes into the predictor is influenced by those labels. And then we say, well, let's train on 1, 2, 3, and 4. Well, labeled information about 5 is in the data. So it's a little weird. It's data leakage. So strictly, of course, when you use a target encoder, very obvious that data leakage and very big impact on how it influences model development. Scalar, so my rule of thumb, so going to what I like to do in practice is, strictly speaking, I like to do this here. Strictly speaking, I like to do this, but I understand this is faster. So before I do this, I do ask myself, are there any of those transformers that are using the labels? Because I know I'm going to have data leakage in this last case, but I know it's faster. But it's okay, to be honest with you, if our transformers doesn't use the labels. It's definitely out of the picture if our transformers do use the labels. So what I'll do is maybe I'll do this approach here first, because it's faster. That might narrow my candidates down, but I do this at the end, because this here's proper, no data leakage occurring. All right, glad I'm making my point well made there. So given this discussion here, I'm guessing this nested versus non-nested is one way to circumvent some of the issues. I would have to spend a little more time on it, learning what it's doing. So I don't want to spend, I don't want to have office hours, 15 minutes me reading this, but I'm going to make a note of it because I do want to come back to it and explain it further. So thank you for bringing that point up. You just have to wait a little bit longer for me to come up with a proper explanation of what is this article in scikit-learn describing. Okay. The article seems to suggest that even in the first case, we shouldn't rely on the score from a single test set on the pipeline. Instead, we should nest the pipeline within other CV results to get better estimators and generalization. Yeah, I'll take a look at it more closely, but thank you for pointing that out, Narayan. Okay, so let's go back to this case here. Did take a detour there, but I think it was worth it. So now, as always, I'm going to take a look at the code I wrote and be critical. And a couple of things I don't like is we're using this toDateTime function. And what is nice is that I don't have to specify the format. Where it is, let's see, format. Don't have to specify that. However, I can specify the format and it will speed things up. So for example, let's go here. Let's run this and we'll use time it. That took about 4.3 milliseconds. Not too bad. Well, let's see what happens if I had called to date time, but I specified the format. And I said the format is capital Y, which stands for 4-digit year, capital M dash capital D. And that took 3 milliseconds. So it took a little faster, not that much faster, but a little faster, because now I'm telling pandas what the format of the datetime is. Previously, it had to guess what it was. But now, since I tell the format, it can it's a lot faster converting that string into a datetime object. So it's a little faster. So maybe I want to incorporate this into my transformer. Maybe I want to give the option to my transformer where one can specify the format. So what I'll do is I'll say format, and I guess format is a reserved word in Python because of the format method of the string. Let's see. Yeah, a little annoying. Format. And let's just call it format. Oh well. Set that equal to none by default, and say self.format equals format. So then here, I will do the conversion. I will say format equals self.format. If I look at the documentation about format, it defaults to none. So that's perfect. So now when someone creates an object of this transformer, they can specify the format to use if they want to. If they do, then that is used. And since set format equal none is the default, this works out beautifully. Do that right there. Self.format. And now I can specify it, or I cannot specify it. So if I wanted to, I can say, how about I give the format? I got a type error because I think I have these flipped around. M and D. Yeah, there you go. So that's great because I have that capability. It's a slightly faster, so maybe it's not too important to do, but now I have that as my feature in my model, my transformer. Something else that I don't like here is I just don't like how I have the to date time happening in transform. Maybe what I should do instead is create a separate method and call it convert to datetime. This should accept a series, and it should return PD to datetime, my series, format equals self.format. So now I can just say T1 equals convert to datetime, do the conversion, and then just return the difference. So I wanted to, I can put this in a separate method if I wanted to, and it's self.convert. I can do that. Not sure quite how important it is because, well, it's not like I reduced lines in my code, but that's a different variation it could have taken. A type error, so let's see my mistake there. Yeah, because I forgot about self. So maybe it's not worth it because it's going to open me up for more errors. But nonetheless, I think having the format feature was crucial. Questions we will have before we march on? All right, go and march on. So here's the cycle 1 columns and the cycle 1 features. I don't recall what the cycle 1 features were. I think I know what to do. Oh, okay, there's a feature. Sorry. Yep. So now with the columns, what I can do is, let's see what approach. I think I've been doing the column select transform approach. Column select transformer and say, okay, we'll work on these columns. And now my workflow will be the business features, the cycle 1 features, and the time features. And now I can add my estimator, my regressor, and I'll just choose linear regressor. In fact, we say random forest. But I actually like to use a simpler model. I like to keep it simple first. We can always use it as benchmarks. sklearn linear model, import linear regression. From sklearn pipeline, import feature union. Okay, name error, because I have to define business feature. Because there's probably some cell up above that I just killed running. Let's see where that appeared. It might have been a Q4. Ah, it was Q4. Doesn't know what categorical features are. I'll just comment this fitting piece. Okay, I think I have everything together. Okay, and let's bring everything together. All right, got a type error. I think I know what the error is. I kind of anticipated it. Yeah, not supported operand type O for datetime for D-type float 64. So let's see what could have gone wrong there. So this is what happened, the final error message. And what I like to do is I like to move back until I find the code I wrote myself. Lots of stuff going on, but I'm trying to look for the code that I wrote myself. That might clue me in to where I should start looking. And survey model.fit. Let's see here. And it's calling on pipeline, pipeline, memory, pipeline, 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 parallel, 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 backend, pipeline, and construct, and type error. So somehow I have a D-type O as opposed to a float. So somewhere on the line it was not able to properly process something. Let's think, what could be the issue there? I might look at, maybe it's what's going on here. Maybe that's what's going on. So what I'll do, if I suspect that something's wrong with my time features, let me back up and construct a model that simply relies on those time-based features. Model time pipeline, and I have let's see. Time, and that's my time delta. And just copy that right there. Then my regressor. Let's try it out. value error. Okay, so maybe that is the issue. Expected a 2D array, got a 1D array instead. Remember how our transformers in scikit-learn, they want to make sure that they return 2D arrays. So we can make that fix. And we can say reshape. Well, what comes out as a series, so we'll values, and we'll reshape -1 to 1. We'll make that fix. Let's try it out. And I got something that appears to work, at least for fitting. Let's see if it works for predicting. Yeah, get a set of answers. So now maybe this is the issue. And I still get the error. So maybe something wrong is maybe my business features. Maybe the fact that let's see what's going on here. Business features, categorical features, simple features. All right, let me uncomment this. Type error. So it is the problem, not with my time-based one, but something with my business model there. Oh, something is going afoul there. Did I forget to do the 2 data frame? I think I did. I think I really should have had my first step here should have been 2 data frame. Nope. Still get the error. Let me see what's going on in the chat. When we were using the pipeline with a categorical feature exercise, was it a scalar that's 1 transferring the Boolean values to 0 and 1? So let me take a pause of that. When we were using the pipeline with the categorical features, was it the scalar, the 1 transferring the Boolean values to 0 and 1s? Encoder, I don't think we have. Are we referring to this right here, Mickey? This right there? Are you referring to a different line? Yes, okay. What's happening here, why this works out, is if I take fine counts, well, let's see, values count, well, actually, and unique. There are 7 unique values of that column. So if I had done something like this here, then since there are 7 unique values for fine counts, then it would have been a 7-class classification. Since there's 7 unique values, so that's what happens when you give a classifier in scikit-learn a series, the y vector. What it does, since the model is a classifier, it looks at the y and says, how many unique values are there? Oh, there's 7, so it's a k-class classification problem. But since what we did instead is we said find counts greater than 0. Well, this is going to return to a Boolean series, so only 2 distinct values. We can prove it to ourselves by saying unique, true and false. then this makes it, so this here, and 0, using the greater than symbol, operator, we make it into a 2-class binary classification. So it's not about what's happening on the X, but it's what happens with the Y. So where, let's see, I think some of that, let's see, categorical. The one-hot encoder, yes. So I think I may have answered the wrong question. The one-hot encoder is what's converting those true and false to zeros and ones. That is correct. Okay, I'm trying to figure out what is going wrong, and I think I know why. Do I know? Okay. Simple features. Let's see simple features. Oh, it already has a 2 data frame. It already has its own 2 data frame. In the business model, categorical features already has a 2 data frame. So it's redundant to have that 2 data frame step occur twice. So this is redundant. So feature union runs it through business features, cycle 1 features, and time features. Let's see if the cycle 1 is not the problem. I don't know why tab autocomplete isn't helping me out here. Something's going wrong. Kernel reconnect. Let's kill that there. Now I'm being impatient. Okay. Can't even find the code that I wrote. Alright, that works. Cycle 1 features work. So that tells me, if I were to comment this out there, the value error I do, I guess I didn't fix up what I did. I should run that. So one more time. There you go. That fixed it. Okay, so definitely something wrong with my business features. So notice my debugging approach is basically take each step and test them out myself and see if it's working. Well, now that means my business features is the problem. So there I invoke my type error. Data type O to data type float 64. So something is amiss here. If I look at my business features, it's a feature union. So if I say steps, maybe. So simple and categorical accepts the toDate, column transformer, selector, and transformer, followed by the encoder. So this error suggests to me type O, type object perhaps. Okay. So I think what I'll do is, let's get name steps. I want to see if I can pull out, I want to test out the individual steps. That's my next approach. Transformer list might be able to get me that. So I say 0, and let's try the first one, fit and transform. Data, the tuple. Oh, because I want the 1 index of the tuple. Well, that works out. Business feature appears to work out. I have some missing values. So perhaps I'm missing a step in the way I have my business features. That's probably what's going on there. So I guess I'm missing my imputer there. Let's look at the next one. And there's my sparse matrix. So something's afoul, I believe. With this pipeline. To data frame, select these columns. Which is a categorical features. Oh, well, sorry that I spent most of the time trying to debug what's going on here. So I know something's wrong with business feature, and that's kind of annoying because that's the part I didn't work on because I was out. So maybe I should have solved this one first, even though y'all saw the solution previously. Yep, same error. Simple features. Did I mess around with simple features? Just run this again. Did I think it was missing the imputation step. Oh, I had a separate step after the simple features. So this is telling me that I'm missing that imputation step. So I think I need to wrap my simple features in a pipeline. Let's see what happens here. Imputer, simple imputer. Let's see if this works out. I still get a value error. Oh well, different error. Couldn't convert this string to a float. For some reason, something is mismatched in my columns. We ran out of time. I probably should have started off with Q4, given that I was out. Oh well, I'll let Russ fix it for y'all. So sorry about that. I spent most of my time fixing that. With that said, everyone, I have to head off. Take care. Have a good rest of your day, and I'll see you back on Thursday.